So in lesson 7.3, we're going to look at how to factor polynomials. So we're going to work backwards from what we've been doing, which was multiplying them and getting, a trinomial or a polynomial with more than 3 terms. Now we're going to work backwards and we're going to factor them. So we're going to do this by finding the greatest common factor of the terms, and then we're going to factor that out and then see what it looks like written as an expression that needs to be multiplied to get back to its original form. So let's first look at this polynomial. So this specifically is a trinomial, right? Because we have 3 terms here. Now we need to find the greatest common factor of the coefficients, 12, 8, and -6. We also need to find the greatest common factor of the exponents, the variables, with the exponents. So let's just put this into perspective. What exactly are we saying we have here? Well, over here we have, so we could factor this out. 12 is 2 times 2 times 3. So if we were thinking about using the prime factorization tree, we would get it down to 2, 2, 3 for our factors of 12 that make 12. And then we have 5 x's being multiplied, and everything's being multiplied together. Over here, we would have 2 times 2 times 2, right? 4 times 2 is 8. And we would have 4 x's being multiplied together. Over here, we'd have a -2 times 3, and then 3 x's. Now, once you find the structure and how this is done, you don't need to write these out every time to find the greatest common factor, but it's important to start this way because this is actually reinforcing what exactly we have in these terms. So this first one, let's look at the coefficients first. Now, these two have a 3, but this one does not, which means we can only pull out a 2, right? Well, since we needed one of these to be negative, we're just going to pull out a positive 2 and put the negative there. That still shows -6. So we're going to factor out a 2 for our coefficient. They all have those in common. Then we look at the x's. What's the maximum number of variables that they all share? Well, this one has 3. This one has 3, this one has 3. So really I'm looking at the lowest exponent. And if they're all the same variable, they're all the same base, that means that that's going to be the greatest common factor, is the lowest one. So we're going to do 2x cubed is our greatest common factor. Now we have pulled those pieces out. So now we're going to look at what do we need to multiply the 2x cubed by to get back to our original polynomial. So we're just going to start at the beginning. 2x cubed times, I need 12x to the 5th, so that would be 6x squared. Now let's check this. 2 times 6 is 12, and x cubed times x squared gives us x to the 5th. Next, we'll look at getting to 8x to the 4th. Well, I would need a 4, and I need one more x, so I just do 4x. 2 times 4 is 8, and x cubed times an x gives us x to the 4th. To get -6x cubed, I just need to multiply this times -3. The x cubed is already in the term. Check it. 2 times -3 is -6, and then we have x cubed. So this is the factored form of this polynomial. That's all we have to do as of now. We will get into some other ones later where we're going to actually factor it into, instead of just a monomial, it might be a binomial and a trinomial or something like that. So they will get a little more, advanced, but right now we're just factoring using greatest common factor. We pull it out and we rewrite the rest of the expression. Let's do another one. Let's do this one. Okay, so let's try this without doing our prime factorization model. Let's just look at what's the greatest common factor of the coefficients and the greatest common factor of the variable terms. Well, -18, 6, and 24. I know that 6 can go into all three of these numbers, and this is the only one that's negative, so we're just going to factor out a positive 6. Now look at the y's. This one is the smallest, y squared, and there's two y's in each of these, so we can factor out y squared. So 6y squared is our greatest common factor. And now we're going to write what we need to multiply times this to get back to our original. So 6y squared times -3, I need 2 more y's, y squared, will give us -18y to the 4th. 6y squared, we need 6y cubed. Well, we just need to multiply it times 1, so we don't really need to write that coefficient, but we just need to multiply it times a y to get 6y cubed. Over here, we need 4, and the y squared has already been factored out, so we just need to multiply it times 4. So this is our factored polynomial using the GCF. Okay, one more thing. You might encounter something like this. Now we can see here that we don't have any coefficients other than 1 that's the greatest common factor of these three. So we're not going to be able to factor out a coefficient, but we can factor out an x because they all have at least 1. Since this one only has 1, that's all we can factor out. Now we're just proceed as normal. We would need x squared times x to get x cubed. We would need 5x to get 5x squared. And we would need a -22 to get -22x. So in some cases, you're only going to be able to factor out the variable, and that's okay. You might also see something that looks like this. (2x cubed minus 5x squared plus 25). Now, in this case, we don't have a greatest common factor other than 1 for 2, 5, and 25. We also don't have a greatest common factor in variables because these have x's and this one does not. So in this case, there's no greatest common factor other than 1 that we can pull out. So that means that this is already fully factored. And that might happen. It's going to test your ability to see what can actually be factored out. And in some cases, it might not be able to be anything. But always make sure that you look at your coefficients first and then your variables. And now it's time for